Example 2, this is from the exam 2 from 2006. A new shopping centre called Shopper Heaven S is about to open. It will compete for customers with Easttown and Knoxland. Market research suggests that each shopping centre will have a regular customer base but attract and lose customers on a weekly basis as follows. Much like the previous example, I'm going to fill it in as we go. So 80% of Shopper Heaven will return to Shopper Heaven next week. We'll put that in there. 80% is the same as 0.8. 12% of Shopper Heaven will go to Easttown next week, so 0.12. So that means the final one here has to add up to, just get that so it doesn't look like a 6. So the last one, it's 80 plus 12 is 92, so that's going to be 0.8. 76% of Easttown will return to Easttown. So here's our first trap, because some people might just fill in the columns like that. 0.09 will go to Shopper Heaven, and 0.15 will go to Knoxland. 0.85, love their Knoxland. 0.10 will go to Shopper Heaven, and 0.05 will go into Easttown. So again, we're going to just load this up into our CAS because we're going to have to do a calculation with it. During that week that Shopper Heaven opened, it had 300,000 customers. In the same week, Easttown had 12,000 customers and Knoxland had 880,000 customers. We need to fill this in below. So here we go. We're going to put that 180,000 there. We're going to put that to 120,000 here. This is that lovely column matrix that we need to do. And there we go. And in that exam, only 65% of the state got 3 marks for that. And I think many, so many of them just wrote it out as per the order, or they didn't put it in proportions. So use T and K naught to write and evaluate a matrix product that determines the number of customers expected at each of the shopping centres during the following week. So we just need to multiply our two lovely friends here. So for this kind of business, we need to write and evaluate a matrix product. That means that we need to write the full equation. You can't just put an answer. As soon as it says write and evaluate a matrix product, we need to actually write this whole thing. Although I'm lazy, so I'm just going to copy and paste what I've written here. So I'm going to multiply these two together. So I've made it explicitly clear which shopping centre is which and which number it is. Now you might be wondering, oh, good heavens, do you have to rewrite all of these, the whole matrix each time? Well, you could get away with writing T times K naught is equal to, and then just write this final product in there, and therefore finalize these answers. If it were me, I would write the matrix, but yes, this would be a minimum that you would write, that you've got T and you've got K naught in there as well. Just be careful though. If you're going to write this, you better make sure that you've written T naught, the transition and the K naught correctly. Or you haven't written them incorrectly. So just make sure, just triple check everything you're doing there so that you are not making any mistakes. Show by calculating at least 2 appropriate state matrices that in the long term, the number of customers expected at each center each week is given by the matrix K equals this. So we're going to need to do 2 multiplications, and so essentially what this means is we need to prove that this is the state matrix. So all you would need to do is set up 2 equations. So what I'm going to do is I'm going to start by doing K50 is equal to, and I'm going to get my 0.8. So I've set up my first equation. And I get this 194,982 point, etc., etc. And then for the next one, so it's going to be steady state if the next matrix after this is going to be the same, if the final answer is going to be the same. So the easiest way to do this is to set up our matrix from before, multiply that by this answer, and there we have been able, and so by multiplying those, we have been able to demonstrate that that is now a steady state solution. Only 20% of the students got 4 marks for the last, for C and D, and often it's because they didn't write a full expression, or they didn't label things correctly, or just put final answers.